In this video, we're going to walk through solutions to some of the practice problems for our lecture on atomic structure. So we're starting with this first problem about writing out an element symbol based on the protons, neutrons, and electrons given. Hopefully you've tried this already. If not, pause and give it a shot. And so for each of these, we're going to want to include the charge, the mass number, and the atomic number. And then we'll decide if we have different isotopes, ions, and elements amongst these ones we're drawing. So let's start with our first one right here, A. So for number A, we have 34 protons, 42 neutrons, and 34 electrons. So what I'm going to do is I'm going to go look on the periodic table for the atomic number 34 and see which element it's actually describes. And it's going to be selenium. So I'm going to start by putting an SE for my element symbol. And my atomic number is the number of protons, and that goes on the bottom for my element symbol. So it'll come down here in the lower left-hand corner. Remember, for any generic element symbol, we have our atomic number on the lower left-hand side, our mass number on the left upper hand side, and we'll put charges on the right hand side in the upper right hand corner. All right, so next we need to know what our element symbol is, or sorry, our mass number is. And our mass number is always going to be our neutrons plus our protons. So in this case, it's 34 plus 42. So that's going to give us a total of 76. And our charge is neutral, right? Because the number of protons and electrons are exactly the same. So if I subtracted them, 34 minus 34, I'd get 0. So there's no charge here. I can put a 0 here, but it's kind of redundant. I'm just going to assume if there's nothing written in that corner that it's a neutral atom. So I can leave it off. All right, so that's A. Let's look at B. B also has 34 protons. That means it has to be selenium too, and I'll put my atomic number of 34 at the lower right-hand corner. Now this time it has 44 neutrons instead of 42. So that 44 plus 34 will be my mass number. And so when I calculate that, I get 78. And now looking at my protons and electrons, I have 34 for each. That means it's a neutral atom, so I don't need to write a charge on the right-hand side. All right, C. 34 protons again. It's selenium. And I know my atomic number is 34. That looks like a 9. So now looking at this, I have 44 neutrons again. So I have the same number I did for B. That means my mass number will be the same. It'll be 78 again. But this time I have 36 electrons rather than 34. And so if I just do 30, so I've got 34 protons, and I have 36 electrons. They are negatively charged. So that's going to give me an overall charge for the atom that's -2. So I'm going to write that in that upper right-hand corner. All right, let's go to D. 36 protons this time, so it's not selenium. So now I'm going to go look at my periodic table and find the number 36, and that should correspond to krypton. So I'll start with my element symbol Kr and add that 36 at the bottom right-hand corner. And now I need to determine that mass number for it. So I've got 44 neutrons again. So 44 plus 36 is going to give me 80. So I'll replace that with 80. And comparing my electrons and protons, this time they are the same, so I'll have a neutral atom, so it won't have a charge. So here are my isotope symbols for all A through D. Now the question is, which ones represent 2 different isotopes, 2 different ions, and 2 different elements? So when I'm looking for 2 different elements, let's start with elements. I'm looking for something that's going to be different symbols. And so for this one, it's really krypton, and any of these are different elements. All right, now let's look for a set of different isotopes. This is going to have two different mass numbers, but otherwise everything will be the same. And so my eye's drawn to A and B because these mass numbers right here are different, but the charge and the element is the same. So these will be different isotopes. Sorry, spelling isotopes wrong. All right, now different ions of one another. So these are just going to be different charges. And so looking at this C, it's got a -2 charge, and B is neutral, but otherwise has the same mass number and the same atomic number. So I would say these two are different ions of one another. All right, so that completes number 1. Let's move on to number 2. So for each of the following isotopes, list the number of protons, electrons, and neutrons for it. So let's start with aluminum 26. Might help to rewrite this as an isotope symbol. The first thing I'm going to do is run to my periodic table and look up aluminum and find out what its atomic number is. So its atomic number is 13. So I could rewrite my element symbol like this as well. But that 13 is going to be equal to my number of protons. And since this isn't a charged atom at all, it's also equal to my number of electrons. And so to determine the neutrons, I'm going to take that mass number, which is that 26 right here, and subtract 13, and that's going to be equal to 13, which is my number of neutrons. So 13 protons, 13 electrons, and 13 neutrons in aluminum 26. Let's try strontium 87. Looking at my periodic table, I find the SR symbol and then look for the atomic number on that element block within the table. And it is a 38. So I could rewrite this as 38, 87 strontium if I wanted. So that 38 corresponds to the number of protons and the number of electrons because it's neutral. We're not told it's charged. And then that number of neutrons is going to be equal to the 87 minus the atomic number of 38, which will give me a value of 49 neutrons. All right, palladium 108. So I run to the periodic table, I find PD on it, it's in the transition metals, and I could see that it has an atomic number of 46. So I could rewrite this as an element symbol or isotope symbol this way. So I have 46 protons and 46 electrons. And I have a 108 minus 46 neutrons, which is equal to 62. And so that's how I can determine the subatomic particle numbers just from knowing the mass number and the element.